Aaron? Aaron?
Yes, sir.
Sir, can you sound rain?
Okay, sir. Okay, sir.
You also exist. I thought you guys left. Especially my class. So we were doing permutation and how. I can't this could be easy. It's really too much late. How you guys go? Huh? Bike? You have a bike? You have a bike. You know how many of you know how to ride? You? See, we have started, we have finished binomial theorem, we have started, we have finished combination the lesson, right? What? Permutation combinations we have started, and in permutation combinations we have finished what part? Huh? Well, which part we have finished permutation combination? Or and what is that? Fundamental principle of counting. Screen shared, right? Okay. B1, B2, right? We will be doing P1, P2, so you are B1, you are B2. Where is mathematics class? Integration, who is doing integration? Yeah, this one, right? Okay. Factorial, achha, we were in factorial notations, right? We have already, why is this gravitational force here? What I was explaining? I also don't remember. Huh? Oh. Created mathematics? Invented. Discovered and invented mathematics. Okay, hopefully guys, those who are online, you are able to hear me. Okay, so we'll start permutation, and before that, let's solve one or two problems based on counting. What do you say? Huh? Shall we? Fundamental principle of counting. So write down, in a railway compartment, 6 seats are vacant on a bench. So there is a railway compartment and 6 seats are vacant on a bench. Okay. How many ways can 3 passengers sit on them? Yes. Solve it. So for both of you, you guys are not here, so let me explain you. You three, solve it. See, if there are events, okay, like there are suppose m different operations that can be performed, okay, and there is another separate n different events that can be performed. So total number of events that can be performed is m into n. Okay, that's our fundamental principle of counting. Yeah, we have done it, don't worry. Okay, we have done it in details to solve this problem. Ashwin, why you guys were not here? Have you, how many days you were not present in class, in mathematics class? Why? Any reason? Actually, it doesn't matter what reason you had. It doesn't matter. Were you there? Okay, fine. Just learn from the examples. That's what I'll say. Murli, you were present in all classes, right? See, there is a train compartment, right? We have done in previous class. Not exactly this problem, but these type of problems. And 6 seats are vacant. Right? And there are 3 passengers. Let's say A, B, C. These are the 3 passengers. So how many ways we can fill this? Because all need to be filled, right? All needs to be filled, right? But there are only 3 passengers. How you process for this one? See, vacant seats are 6. 1, 2, 3, 4, 5, 6. Question: is there any problem in understanding the question? No, right? Question is clear to you all. All right. I'm not giving the solution. Try it. You were there. Did you solve exercise 7.1 and 7.2? Biology? No. See, that's the thing. You have to practice it. I suppose that day you must have understood what we were why and why or, right? By the way, and means multiplication, or means addition. You should be present in class for that. So it's the same principle we are doing. It's the same principle. Okay, Murli? Just try to understand. You have also not solved. You have done. Have you solved examples? No. Solved examples, there are problems. Okay, do it. See, in how many ways A can, where A, just understand like this, biology. Where A can sit, which place? Any, right? So for A, there are 6 possibilities, anywhere it can, A can sit. Okay, A can sit on any 6 of the seats. Now, if A has already occupied one of the seat, so how many ways B can sit? 5. 5. And seat 4 because now only 4 seats are remaining. So in that C can sit in 4. Sorry, 4. Where is B? And what we will add or multiply? Why? Because all three need to be sit. All three need to sit there, right? So and A need to sit, and B need to sit, and C need to sit. So you will multiply. How much is that? 6 into 5 into 4. That will be 1. So 1, yeah. Any A can sit. Let's say A has occupied this place. Okay. So A, see, when there are 1, 2, 3, 4, 5, and 6 seats are there, right? Just understand from here itself. So 6 seats are there. When you are the first person to enter this class, so it's up to you where you want to sit, right? So you can sit on any of the 6 seats. But once you occupy that one seat, then whoever will come, let's say biology one is, then she has got only 5 options. Right? Understood? Okay. So, yeah. Have I taught you formula? I have not mentioned formula. First, understand the principle of counting. Permutation and combination is really easy chapter if you understand how to count. Formulas. We are counting. These are all counting in permutation of. This is the method of counting how that's why we are using small numbers. When we are using large numbers, we cannot form all like 120, 5, 6, so we can even write 120 combinations. But it will take time, obviously. But if it is 1020 combinations, will you be able to write all the combinations? You will, but it again it will take like 10 hours more. You don't want to solve one problem in 10 hours. All right. So we are only doing fundamental principle of counting. All right, let's do one more problem. Okay, hopefully this was clear to you all. Okay, a team consists of 6 boys and 4 girls. We did this problem, right, last class? Have we? Yes. Okay. And the other has 5. Okay, a team consists. So there are 2 teams. In one team, there are 6 boys and 4 girls. In another team, you have 5 boys and 3 girls. Okay. How many single matches can be arranged between the 2 teams? When a boy plays against a wait. I think we haven't done this type of problem. Just wait. When a boy. Okay. See, in this problem, a boy will play against a boy and a girl will only play against a girl. So we have 2 teams. Let's say team A and team B. Okay. 2 teams. In team A, we have 6 boys and 4 girls. In team B, we have 5 boys and 3 girls. It's the condition given is boy will play only with boy and girl will play only with girl. So I think so far question is clear to you all. Okay. Now, how many single matches can be arranged between 2 teams? That means let's say B1, B2, you have 6 boys, B6, B1, B2, you have B5, 5 boys. So matches can be played between this or this. B1 can play with either 5, again B2 can play with 5, till B6 they can all play with 5. And again same goes with girls. Right? So girl 1 can play with either of the 3 girls, girl 2 can play with either of the 3 girls, right? Like that. Now find out and or statement. Is the question clear to you all? Okay, I'll just write it here. Boys can only play with boys and girls can only play with girls. So how many matches can be possible between these 2 teams? That's why That's what your question is. So how you will select number of boys from team A? There are 6 boys, so there can be 6. Okay, first you give it a try. Girls will also play with girls. Remember that. Show me your solution. Yeah, correct. See, boys will play only with boys. So there are 6 boys in team A, right? And 5 boys in team B. So these are the possible combination of matches. So there are how many? 30 possibilities, boy versus boy. Now girl versus girl. There are 4 girls in team A. This is boys, right? And in team B, you have 3 girls, right? So how many possible combinations? 12. And either the boys will play or the girls will play, right? Boys and girls cannot play together. So or statement. So whenever we have or statement, what we do? So 42. Got it? I think counting now, are you able to grasp counting? Don't see when you are solving permutation and combination, just because you need to finish the syllabus, it's not like just go ahead with formulas. Don't do that. Formulas alone will not help. Okay, you will get confused unless you understand the difference between and or. Okay, because either the boys will play together or the girls will play together. They do not play with each other, right? That's so you will just then you will just how many total number of participants are there? So 6 plus 4 multiplied by 5 plus 3. So this will be number of teams, right? So if all can play with each other, so that means 10 multiplied by 8. So how many possibilities? 80, right? If all can play with each other, that's what. Understood, no? Why 80? Anybody. That means there is no girl, boy, doesn't make sense. It's just person. Right? That's what we want in our society, isn't it? No, that's actually we want. Anyway, factorial notations. Let's do some of the problems based on factorial notations. Have I explained factorial notations? In binomial theorem also, we have done factorial notations, right? Let's solve some of the problems. Okay, so find out this. X plus 1 factorial is equal to 12 times of x minus 1 factorial. Find the value of x. What? Do it. Don't know how to do it. For that, you have to come to class. Find out some things. What happened? Solve it. Why you are turning those pages? What is the solution? Are you allowed that notebook in your exam? No? Then try yourself. try, fail, that's fine. But if you want just the solution, you will never get. So don't just seek solution. Find out the method. Yeah. Sorry. You were absent. You know factorial, right? How you are solving factorial. Why you were absent? Huh? 3 what? Acha, x is equal to 3. I don't know. I'll have to solve. Factorial, you guys know what a factorial. N factorial, you know how to write n factorial? Yes or no? Yes or no? Yeah, that's what. If you know that, how can you not write this? Right, biology? See, and try to find the value of x. Only what happened? Biology do this. Second biology, first biology. Find x. What happened, Sham? Okay, I was finding. See, mathematics is all about practice. If you won't practice, see, Murali, what happened? Almost how long you are taking? Almost. What happened to you? This much time, please don't take this much. 3, how you are getting 3? Quadratic equation you got. Okay. What are the values of x you got? -4 and 3 and y. Factorial, negative of factorial is not possible. Okay. So 3 is your answer. Second one, how much you got? 60? Are you sure? Check one more. You also got 64. See, first one, I'll do the solution for first. See. Solve the quadratic. Yeah, just solve the quadratic equation. Will you do the second one? Achha, question is this. Biology do this. That you are correct only. Let's not waste time. Find LCM and HCF of 6 factorial, 8 factorial, and 9 factorial. Okay, for this I'll write down the solution for those who. Okay, see x plus 1, you have to write in terms of x minus 1 factorial. Okay, how you can write? So x plus 1 factorial you can write as x plus 1 multiplied by x plus 1 minus 1, that will be x multiplied by x minus 1 factorial, that is equal to 12 times of x minus 1 factorial. So x minus 1 factorial, x minus 1 factorial you can cancel out because this will be equal to 1. Now you have got a quadratic equation, that is x square plus x minus 12 is equal to 0. If you solve this quadratic equation, you'll get two values of x, that is x is equal to minus 4 and x is equal to 3. Since factorial of negative number is not possible. Okay. Okay. So x should be equal to 3. That is the answer. Understood? What? Understood or not? I don't think so. Any? Okay, so this one, biology, second part. Sorry, second biology. Then? Yes, sir. Sham. Having doubt, you can ask. Yeah. LCM 9 factorial and HCF 6 factorial. Okay. Check one more time. If you have down, just go through it. How you get it? Okay. 64 is correct. Second one. Yeah. Third one. You can explain what it is. Yeah, that's what it is. How you find LCM and LCM? You know what LCM is? Huh? What is the LCM of 2 and 3? What is the HCF of 2 and 3? 1. What is HCF only? What do you mean by that? But highest common factor should be higher now. Why it is 1? Right. Can I? Question. Okay. Question is this. Find LCM and HCF of those who have done 6. Third one. Second, do the third one. Biology, one more question for you. Prove that 33 factorial is divisible by 2 to the power of 15. 15. 1 5. The index is 15. Right? Just we need to write how you will proceed for this problem. See, when we are saying divisible, that means you should not be getting a fraction. Number you should not be getting fraction. Okay. Just write down 33 factorial in terms of n minus 1. You will get your answer. Everyone those. Achha, second problem I'll solve. 64 you got? Okay. Listen. This can be write 1 upon 6 factorial plus 1 upon 7 into 6 factorial is equal to x upon 8 into 7 into 6 factorial. Huh? Is that okay? Ashwin, is that okay? See, n factorial, though n factorial can be written as n into n minus 1 factorial. Okay, n can be any natural number. Even it cannot be whole number. N is not a whole number. That means n cannot be 0 here. So n is 1. 1 is equal to 1 into 1 minus 1, that is 0 factorial. And 0 factorial is always equal to 1. We have proved that, right? We have done that in class. Were you there? You weren't there. Very good. So this we can write. All right. So from here we can write 1 plus 1 upon 7 is equal to x upon how much? Or we are taking this 1 upon 6 factorial common. How much? X upon 8 into 7 is how much? Yeah? Huh? Louder. What? How much? 56. Now solve it. Solve for x. What? Third, LCM and HCF you have to find out. For you have already said now 1 and 6. Okay, sorry. This 6 factorial, 8 factorial, 9 factorial. You done? Okay. Let me finish this one. See both of you. These two can be cancelled out now. Same term. Okay. So how much will be this? Left hand side is how much? 8 by 7. Is it or not? Fast, fast, fast. Fine. Yes or no? Yes or no? Chan, you understood? Okay. Dude, you have to say something. Okay. So else. LCM and HCF. Murli, you did? You tried? Not sure. Okay. How you process? How you will proceed for this one? Just write down, no? 9 factorial is equal to what? You have to write everything in terms of 6 because 6 is the smallest number, right? 6 factorial is the smallest. So write first 9 factorial in terms of 6 factorial. How you write it? 9 into 8 into 7 into 6 factorial, right? 8 factorial, how you will write? 8 into 7 into 6. Now write, now do it. I think now you can do it. Okay. And 6 factorial, right? So that let's write like this. Now I think you can solve it. SCF is 6 factorial, okay. And LCM is 6 factorial, yes. LCM is 72, okay. And what is LCM? Lowest common factor, right? Least common multiple or lowest common factor, that is, both are same, right? Is it or not? No, it's not. Factor means multiple. No. Then why it is called LCM? Least common multiple. Okay. Yeah, do it now. Huh? How to do? Next question you are asking, right? I thought you have already solved it, so just wait. If I'm explaining again, I'll have to explain you just write 33 in terms of factorials, okay, and try to find out in like it will have terms 2, 4, 8, right? These terms will be there, and these will be powers, right? 2 to the power of something. 2 is 2 to the power of 1. 4 is 2 to the power of 2, right? So you are adding all the powers. Just write that method. Okay, I don't know LCM. LCM is obviously from here what you can say. It is 9 factorial, right? LCM is 9 factorial, HCF is what? 6 factorial it is. How? Explain. Biology. First you tell me LCM of 10 and 15. How do you find LCM? Write down. Find out LCM and HCF. I want to see the method here. I know it is 30. Is it 30? Is it 30 though? Okay. It's really easy to confuse you guys, right? Least common factor. Okay, I'm not here for that. I'm sorry, I did that. Oof. You are designing something. Biology part 2. I can see. Murli, you're understanding, right? What you will do? You will try to find a number which will be divisible both by 10 and 15. So which is that lowest number? 30, right? That's what the meaning of LCM is. Okay, you'll find a number which is divisible both by 10 and 15. 10 battery, this was for pencil, right? So 10 and 15. So 30 is the number. You just this how you will find it? You'll find the factor. So, okay. How? Why is that? So, but why you are leaving 6 factorial? It will be, see, LCM of this will be what? 9 into 8 into 7 into 6 factorial, right? Is it or not? And that is equal to your 9 factorial. I don't know the value. Now you are telling me that 9, 8, and 6. Why you need 7? See, if there is a number M and there is a number N, right? M and N are two different numbers. We don't know what how do you find the LCM? In similar manner, you can not all, not because 9. If you are like this, so I don't exactly know how much value it is. This is how much what is so any number is 720 multiplied by 8, right? Into 7. Multiplied by 9. are saying, yeah. So obviously you are leaving these three numbers. 9, 8, and 7 you are taking out. You are taking out the multiplication of that. You understood what you are doing from the so the HCF will be how much? HCF is 6 factorial, right? What is HCF? HCF of 15 and 10. How do you find? What is HCF of 15 and 10? How do you find HCF? What is the HCF of 15 and 10? Why it is 10? 5 it is, right? What is you don't know how to find LCM and HCF. Okay. Let's write down the multiple. 10, 2 into 5, right? Yes. 15, 3 into 5. What is HCF? What is HCF? Highest common factor. Which one is the highest common factor here? 5. How you said 10? You also said 10? Dude, just go and learn HCF and LCM first. Understood or not? You are not confused with LCM, HCF, right, Sham? Or you are also confused? LCM you have problem with. No, you LCM don't know. Okay, then you don't have problem with it. Okay, fine. You have, you are saying no, but I can see you are saying yes. So yeah, answer you already said. It is 9 for HCF. Will be your 6 factorial LCM. Yeah, 9 into 7, 9 into 8 into 7 into 6 factorial. So that is what? 9 factorial. No need to calculate. Whenever you have problems like this, you don't have to calculate. You keep on multiplying 9 into 7. Don't do that. In the first class only I have said this. Don't go doing that. All right, let's do the next problem. Where is the next problem? Biology. Okay. You got it? You proved it? Somewhat. How you did? See, the question that I gave you is prove that 33 factorial is divisible by 2 to the power of 16, right? That's what. Okay, 15, fine. If it is divisible by 2 to the power of 16, it is divisible by 2 to the power of 16. Okay, now let's write down 33 factorial. How you will start? We have only this information. Let's start from here. So 33 factorial, we can write 1 multiplied by 2, 3, 4, 5, 6, 7, 8. I don't have much patience. 16, 32. Right? These are the terms that will be there. And other terms will be there, right? Like 10. 10 will be there. Okay. Dude, I know 33 will be there. I'm just trying to write multiple of 2 only here. Okay, 10. Okay. If you want, I will write all terms from till 33. Okay. Happy? Yeah. Okay. You want to waste your time, right? 1. I know how to count till 33. Okay. Okay, madam. Let's do like that. No, let's write 27, right? I forgot. 6. Hey, I don't have much vision. Okay. 16, 20, okay, 16. 8. Let's write 4, 2, 1. Fine. These many numbers I know, the rest numbers I don't know. Okay, so 32 is what? You can write 2 multiplied by what? 30. Okay, wait. 2 to the power of 5. 30 is what? 2 into 15. Because we need to find what divisible by 2 to the power of 15, right? This what you can write? 2 into 2 into 7, right? 2 into 2 into 7, we can write that 2 square into 7. We don't care about 7. 2 into 13. This is what? 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, right? So here itself you can see what is this? 2 to the power of 4. Now just add these power itself. 5 plus 4 is when we are multiplying it. So can we, if we are multiplying these, can we add the powers? We can just add the powers, right? We don't need actually 15. 15 we don't need. We just multiply it will be multiple of 15. So we can write these numbers as 33 multiplied by, let's say 2 to the power of 5. We write these together. This. Let's write only these together. Okay, 2 to the power of 5 plus what else? From here 1 2 we have. Okay, from here we have 2 2s plus from here again we have 1 2. Okay, from here we have 5. Okay, sorry, 5 already we have written, right? So from here also you are 2 into 10, right? So that will be again plus 1. So this will be 4 plus 3 plus 2 plus 1. So we have written this. How much will be 5 plus, just add these. How much is this? 20 these are, right? Yes, and multiply all other numbers, whatever number is remaining, like 31, right? What else is remaining? 29. All other numbers, you just write it. You are getting it or not? Is there any problem? See, we are writing these, we need to write in multiple of 2. Okay, we are writing all the multiples of 2 because we need to prove this number is divisible by 2 to the power of 15, right? So if any number is divisible by 2 to the power, if let's say you have two numbers, like P, and I'm saying P is divisible by Q. So P upon Q is equal to some number N. That means it is completely divisible. That means what you will write? P is equal to N times of Q, right? And N is some natural number. We are trying to find that N. Okay. This multiple, we don't need to find that multiple. You're getting it or not? So that's what we need to find out. Now we can write this 33 multiplied by 31 into 29 into all other numbers, all odd numbers, because odd numbers do not have 2, right? Like 19, 17, they are not multiple of 2, 15. So all numbers, all odd numbers plus, not plus, multiplied by all numbers from which we have taken out 2, like 30. We have taken out 2 from it, so it will be 15, right? So those numbers 15 into again like 28. 28 if we take out 2 to the power 4 we are taking out from it. So what it will become 7, right? What else? 26, 13, right? What else? Means all those type of numbers, all numbers. And we have not even taken all the numbers, but still we have 2 to the power of 20, right? This is 2 to the power of 20. If you add these numbers, what are these numbers? These numbers are 32. This is 2 to the power of 1. So we have taken 1 2 from here. We have taken 2 2s from here, from 28. We have taken 1 2 from here, 26. We have taken 4 2s from there, 16. We have taken 3 2s from there, 8. We have taken 2 2s from 4, 2 into 2, right? So we are adding, even here also we have left so many 2s. But okay, let's multiply by remaining 2s. Multiple of 2s. Remaining number which is multiple of 2. So what we can write, this will be some number. Okay, this this multiplied by this multiplied by this will be some natural number. It will be a very large number, but it will be some natural number, right? So can we say that n, that natural number n? Fine. It will be some very big number. Of course, we cannot calculate it here. Okay, multiplied by 2 to the power of 20, right? Can we write this as n multiplied by 2 to the power of 15? Let me erase this. Something is wrong with the book. 2 to the power of 15 multiplied by 2 to the power of 5. Can we write like this? So again, I'm writing combining these two. If you multiply, this is also a natural number. Natural number. This is also a natural number. Natural number, right? Product of two natural number is what? Another natural number. So let's say that natural number is q, some natural number, into 2 to the power of 15. Fine. That means what? This number 33 factorial we can write in terms of multiple of some natural number into 2 to the power of 15, which defines that, which means that 33 means 2 to the power 15 is a what? Factor of 33 factorial, not 33 factorial. 33 factorial is really large number. 33 into 32 into blah 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 blah. Understood? Or still having problem? I'll explain it again. Because see, these type of problems usually, I don't know, now they are not asking in CBSE, but I also studied in CBSE syllabus. I used to have these type of problems. I don't know if they have delivered it or not, because this book mine is from my time. Okay, old age. Alright. So and these type of problems, if you are able to solve, definitely you will be able to solve all types of problems. These are the types of proofs you will find in trigonometry, you will find in complex number. Again, you will find in probability also, like probability distribution of the study. Okay. So try to solve these types of problems. I will give you one assignment in which I'll put one or two questions based on this. Okay. Try to solve it yourself. Just don't try to Google and find the answer. You can find all the answers on Google. Definitely it is something. But how you reach that answer, that is important. Till now, have you understand permutation and combination? We haven't studied permutation. We haven't studied combination yet. Okay, so I'll just give you introduction of permutation. I think fundamental principle of counting and factorial notations. These two are clear, right? NCERT, you can solve all the problems. I don't think there is any problem in NCERT that you cannot solve. Exercise 7.1 and 7.2. Okay. Let's move to exercise 7.3. Yes. Oh, what is the use of factorials? Very good question. See, factorials we study so that we can understand the arrangements. Okay. Like when we are studying, I'll give you examples. Based on those examples, I suppose, like when there are like 6 chairs examples I gave you. When you came, you are the first person. You can occupy any of the chairs. Now here you can see only 10 or 15 or maybe 30 chairs. Maybe suppose there is an event in which stadium is full. Okay, how you will arrange that? Okay, how many people will come, where they will sit, how you will make those arrangements. You cannot go and keep counting and keep giving everyone specific numbers, right? So how computer do that? So for that we need permutations. For permutation for that purpose. Again, I'll give you example. Like timings of flights, okay, or maybe timings of some buses. It's not like one bus is going from one city to another. So several cities are there. Trains. How the timings are arranged. This from from here to here, the speed will be this much. Okay, those calculations are already there. So using permutation only, the timings are decided. Okay, when at this particular time, how many passengers are expected on the airport? So according to those, that security will be arranged. Okay, so these are some of the applications of permutation in the combination. That's why we And to us understand permutation and combination, we need factorial notations. Okay. See, why we use logarithmic function? Because either to decrease or increase the size of what? Increase or decrease the size of what? Number, let's say numbers. If you have something like 10 to the power of 20, you cannot, how I should explain that? Let's forget about logarithm. I'll explain it to you later. But did you understand why we are using permutation? Suppose these are 30 chairs and full stadium full of chairs are there. How you will arrange where, who will sit? So then again we will use permutation and combinations. Okay, these are some of the examples of this. And again we have some of the examples that while we will be solving this, like letters. How many words you can form? How many meaningless words you can form? Those are the questions there, right? So we will solve those two. I'll just give you introduction of permutation, and tomorrow we'll solve a lot of problems based on permutations. Permutation. These are, arrangement. Okay, permutation means arrangement in ordered pair. Not just pair, or in a particular order. Okay, let me write it like that. In order. Arrangement in order. That's how you should write permutation. All right. Write down. And order in linear order. We don't do exponential. Sorry, my mistake. Oh. Linear order, especially in linear order, when we arrange things. For that, we need permutation. That arrangement is called permutation. Okay, like let's take example. If I give you set of number like 1, 6. Let's say these are the two numbers in a set. Okay, how many ways you can arrange these numbers? Either you can use what? One method will be 1, 6. Another method will be what? 6, 1. In first place, first you will take 6, then again. So how many ways are there? 2 ways. Right? Understanding this thing? So in permutation, our order really matters. Okay, in combination, we will see order doesn't matter. In when we are arranging things, permutation means arranging things. Okay, in a linear order. You have to understand this linear order. That means again counting principle will come into action. Okay. Now some of like I gave you the examples of that permutation, right? What like timings of buses, trains, how they are arranged. Like any other example that we can think of, license plate. What? Exam, yes. And see how you will arrange students in a class. That is again there. Like when you have board exams, which school is selected. In that, which rows are even on your desk, your roll number is written, right? Where you will sit properly. So see how many desks are there, how many classrooms are there, right? But still you get your seat. And in all over India, how many people are taking that exam in CBSE? So that is all permutation and combination. Mostly we use permutation and combination for that. License plates, like a 4-wheeler will have different license plate. 6-wheeler will have different license plate, right? 2-wheeler will have different license plate numbers. The number that how they are doing using permutation and combinations. So these are some of the real life examples of permutation and combinations. Okay, so in permutation is defined by NPR, right? Now the formula is coming. Important thing is you have to understand what is the meaning of this formula. NPR. Can anyone tell me what is the meaning of this formula? What is NPR? P means arrangement, right? I told you, no? Arrangement in linear order. So you have n objects. Let's say you have n number of objects, okay? N objects. N objects. Okay, and you have, you need to arrange R objects. let me tell you again. So n objects to be selected. You are selecting r objects from n number of objects. That's what permutation is. Okay? Write down n objects. Okay, so something is wrong here. Not you guys. R objects to be any doubt? You can tell me. It's fine. You both laughed at the same time. Some sync is going on. Huh? Sine and cos are getting merged. Is it? No? Tell me. You understood this? The meaning is very simple that you are selecting R object or arranging in a linear order from n objects. That's it. That's the meaning of permutation. Okay, let's do see. I think giving theories will not help. Just let's do some of the problems and you will understand what permutation is. Only theories will not help. And of course, I told you, right? Order matters. Right? Order will matter. Let's not write that. Please don't write that. I think I'll make this mistake if I'll write. Again, you will ask so many questions. Let's not write that. Let's just solve problems. Okay, how do we define NPR? NPR, how do we define that? This is n factorial upon n minus r factorial. Okay, okay, r can be from greater than equal to 0, lesser than equal to n. All right, yeah. What? Rewrite this formula. Yeah, we can derive this formula. You want the derivation? It's small. It's based on the concept. See, we'll derive formula tomorrow. Okay, if it's okay, because you guys also need to leave. I need to leave for another class. Okay, NPR is N5. Let's do one or two problems based on this. Find out 5P3. We have done this before as well. So just do it. Do few of the problems. And it's really easy, right? Okay. Yeah.
60.
Yeah, R is 0, then we are not that can be there now. How many students failed in class? No one. Or let's say how many students passed in class? No one. So that can be there, right? 15. Okay, let's see. 5 factorial upon 5 minus 3 factorial. How much? 5 into 4 into 3 into 2 factorial. Here it is 2 factorial. How much is this? 60. Okay. 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 If find R, if 5 into 4 PR is equal to 6 into 5 PR minus 1. Find out. Find R is equal to what? See, I'm not going to repeat again the fundamental principle of counting. If you have doubt, please ask me now itself. Just multiply 5 into 4 factorial upon 4 minus r factorial will be equal to 6 into 5 factorial upon 5 minus r minus 1 factorial. Okay, so how much will be this? Do it. So this is 5 factorial, right? 5 into 4 factorial is 5 factorial, right? Please tell me if you have doubt here. 5 multiplied by 4 factorial is 5 factorial, right? Okay. What? This is again your, sorry. 6 minus r factorial. So this, if you will cancel out, it will be 6. Isn't it? Now solve it. 6 minus, of course, 6 factorial will be equal to how much? This will be 6 multiplied by 4 minus r factorial. I don't know whether it will be quadratic or cubic equation. Quadratic, okay. So this you can write 6 minus r multiplied by 5 minus r multiplied by 4 minus r factorial, right? 4 minus r factorial is equal to 6 into 4 minus r factorial. These two will cancel. You multiply this, you will make so r square minus 11r minus or plus? Plus, no, it is 24 will be equal to 0. Solve this equation. You'll find r. Find two values of r. So r will be equal to 3, r will be equal to 8. That means, what's the meaning of this? You just substitute in this equation. That means 4 PR is equal to 4. No. Again, let's not. 8 and 3 both answer you are getting. No? R is equal to 3 and R is equal to 2. R is equal to quadratic equation, 2 solutions you will get. You know how to solve quadratic equation. If you don't know, just find out how to do it. Both are possible. When I said both are not possible, both are possible. What is the meaning of that? If both are possible, just write down in that equation. If both are possible, the meaning is what? 4PR is equal to what? 4P8. That's what you are getting, right? R is equal to 8. Is it possible? Is it possible or not? R is equal to 8, right? One R value is 8 you are getting. So 4P3 is possible, but 4PR is possible, is it? Not possible, right? It is not possible. 4PR is not possible because 4 minus 8 factorial is right. So that will be minus 4 factorial, which is, and negative factorial is not possible. Okay, we have factorial only for whole numbers, not for negative numbers. Okay? So that will be all, and we'll solve based problems based on permutation tomorrow. Okay? So this week, hopefully, I don't know if I can finish this permutation. Thank you so much. Is till now whatever we have done, do you guys have problems in permutation and combination? This chapter. Till now we have done fundamental principle and just the introduction of permutation. In permutation, don't worry, we'll solve a lot of problems, like 10, 20 problems at least we will solve. And I think with all problems, your doubts will be clear. Okay. Yeah, Balaji, any doubt?
Thank you.
Go and read, solve problems. What?